All right, welcome everyone. I'm going to give folks a few moments to join, and we'll do a quick little introduction and then go ahead and get started with today's CEU course. All right, looks like we've got a good amount of folks jumping in the room. So thank you everyone for joining today. I'm very excited to be bringing you today's presentation presented by H-Window. We've got Bryce here who's going to be giving the CEU portion of today's webinar. And I'm from Acelab. We're helping out with hosting today's event. I'm going to give you all a quick little intro just while folks are joining on some information for after today's webinar. So if you're looking to get some more, I apologize, my Wi-Fi's been a little buggy. So I'll keep my normal screen share pretty light, but just want to show you guys where to head if you're looking for some more information about H-Window after today's webinar. If you want to get in touch with their team directly, get product downloads, save their products for later, all of that good stuff. So I'll share my screen briefly and I'll just provide a link to this in the chat as well so that you can access it directly. Keep your eye on the chat throughout today's webinar. We'll send some resources through there. All right. So this is the page that I'll be sending a link over to. This is H-Window's profile on Acelab. You can use this button to get in touch with Bryce directly, connect about projects. That'll create a conversation for you in your Acelab account. You'll also get an email about any new messages, so you can respond that way too. But this is a great place to come if you're looking for some more information about the company in general. You can watch some videos and you can explore some products. You can save these to your projects for later so that you can come back to them. You can also evaluate them against other products. And you can also access downloads, view some more product photos, view some case study information. So this is a great place to come if you're looking for some more information after today's event. We're going to share a link to this in the chat for you. If you're interested in learning some more about Acelab, I'll also share a meeting link for my colleague. You can sign up for a free quick demo. We'll help you out with saving products, accessing downloads, setting up your library, really whatever you need. Our team is here to support you. Other than that, I want to encourage folks to please ask questions throughout today's event. We're going to have some time to kind of pause throughout the presentation and see if there are any questions from the audience. You can use the Q&A box to submit those questions, and we'll keep an eye on that so we can get to your questions live. If we don't get to your question live today, we will have a record of it so we can follow up with you after today's event. All right, I think that's it for me. Bryce, whenever you're ready, feel free to go ahead and share your screen and get started.
All right, well, thank you, Bo, and we're happy to be partners on Acelab and be able to share our content through that platform, and excited to be sharing this session with you all. Would love to connect and hear about ways that we can work with your team and help you find solutions to your projects. I will share my screen here. H-Window manufactures architectural quality doors and windows, timber curtain walls as well. Our high-performance products have unique features and capabilities, allowing us to offer architects like yourselves incredible design freedom and achieve remarkable projects. I'm going to go through really quickly just a few of those products before jumping into our session here. We make awning windows. Everything we do is custom built for your project. Casement windows, direct set windows, large kind of picture windows. A lot of varieties of styles that we can accommodate. Euro lift and slide doors, like other lift and slide doors, we can do very large sizes, up to 43 feet wide. We also do glazed doors. Nordic outswing door is featured here. A lot of different configurations we can do with these. And then our timber curtain wall product, which uses an engineered wood back member instead of an aluminum back member to achieve higher levels of performance and aesthetics. So that's a little bit about H-Window. So I want to dive into the content here a little bit. Like Bo said, I'm Bryce Arstead. I'm the Director of Design for H-Window. So I do a lot with marketing and branding. I do a lot with technical consulting. I am an architect, so I come at it from a design lens, the same as you. I also do a lot of product development too. So wear my hat in a lot of different ways, but all around the topic of design. So today we're talking about regenerative facades. The big question is, how can we as designers, synthesize recent research, codes, building certification standards into facade design principles that will improve lives and reduce energy. We're going to break this down, as Bo said, into 3 different categories here. And then maybe at the end of each one, we'll take a pause for a few questions. The first one is promoting health through biophilic design. The second one, promoting health through indoor environmental quality. And the third one, reducing energy through facade performance. Again, looking at all of these things from the lens of facade development, both in a commercial institutional space, but I think a lot of these principles also apply to residential projects as well. So let's dive in. Let's talk about promoting health and how facades can do that by increasing contact with the outdoor environment. We know that this results in improved human health. We look at some health statistics here, and I'll point to some data throughout the presentation. What we see in the data is that physical and mental health are intrinsically related, and we see that there's a connection between biophilia and health. A few different health statistics here. 21% of US adults will experience some sort of mood disorder at some point in their lifetime. We also know that 50 to 70 million US adults have chronic sleep disorders, including wakefulness disorders. We also know that in green buildings, the occupants of those buildings experience 30% fewer sick building symptoms. So all these things kind of point to the need for facades and buildings, these spaces that we inhabit throughout our day, throughout our lives, to be working with us and helping us achieve better health. So the strategy that we're going to start with here is biophilic design. Biophilic design can reduce stress, can enhance creativity and clarity of thought, and it can improve our well-being and expedite healing. One of the things that kind of as I was entering my career as a designer and trying to understand what biophilic design was, I saw, I don't know if you guys remember, there was a sketch comedy show called Portlandia. And they did this really funny sketch where they had the 2 main characters go into a vintage shop and they were like putting stickers of birds on everything. And they said, oh, put a bird on it. And, you know, it was kind of making fun of hipster culture a little bit. But that was my impression of biophilic design, is just put a bird on it. But after kind of digging into it, I saw that there's actually quite a bit of depth to biophilic design and beyond just put a bird on it. So what are those things? Let's talk about it in three different buckets here. The first one, nature in the space. The second one, natural analogs. And then the third one is nature of the space. So we'll start with nature in the space. And this is, again, looking at it from a design perspective and, you know, having that direct physical and temporary presence of nature inside a space. It's maybe most immediate to think about this as a visual connection with nature. Natural and kind of living spaces and natural processes happening within our view. There's also non-visual connection with nature, connecting to our other senses, hearing, smelling, tasting, feeling, these living systems and natural processes. Non-rhythmic sensory stimuli, unpredictable but naturally familiar sensory inputs. Thermal and airflow variability is another one. Having subtle changes in those temperature and humidity and airflow, and being able to feel that throughout your day. A few more in this nature in the space category is the presence of water. Seeing, hearing, touching water shows nature in the space. Having dynamic and diffuse light and the way that light changes and shadow changes throughout the day. And then connection with natural systems. So having an awareness of seasonal changes and natural processes. You know, being able to see out the window and see that the light is getting different during this period of the year than it is in other periods of the year. Thinking about, you know, how red the light looks outside, the sunlight looks outside in October. Those kinds of connections with natural systems. Let's move on to the next category, natural analogs. And this one is, put a bird on it. So biomorphic forms and patterns, you know, symbolic references to natural arrangements. Material connection with nature, using natural materials with very little processing. And then complexity and order, seeing hierarchies that may be present in nature and adapting them into your designs as well. You can see that here as a geological formation or the formation of a shell. These are ways that you can use natural analogs. And then the last one is nature of the space. So utilizing spatial configurations found in nature. Prospect, the first one here, having views over a wide expanse. Refuge, protected space for withdrawal. Mystery, the promise of something more, but it's partially obscured, partly hidden there. And then peril, coupling an identifiable threat with a reliable safeguard. So the question then is, understanding these basic principles of biophilia, how do then we apply them to a facade? It may be helpful to divide the facade into 4 fields. You have a transom field, a viewing field, a knee wall kickplate field, and a spandrel balcony field. So the transom is kind of anywhere from 7 feet and above in your wall assembly, and then the viewing field is from 7 feet down to about 3 feet above floor finish. The knee wall kick plate is from the floor up to that 3-foot marker. And this, is not scientific. It's just kind of an ordering device here. And then spandrel balcony being that space between floors or at the parapet. So by dividing the facade into these 4 fields, we can then focus on each one individually and apply these biophilic design principles in that way. So let's look at the transom field in particular. Applying nature in the space. This is a field where you can do a lot to control the daylighting within a space. You're controlling that dynamic and diffuse light. You have the opportunity to use biomorphic forms and patterns on this plane as well as many others. Let's look at nature of the space. If you're designing a space to have a prospect, that transom is probably going to be glazed. If you're designing a space of refuge, that would probably be an opaque transom where you're trying to limit how much view space you have. In the viewing field, a few other options here with operable windows for non-visual connection with nature, getting that thermal and airflow variability. And then natural analogs, complexity and order. Maybe you're taking the arrangement of your facade elements and you're doing like a Fibonacci sequence or doing something that evokes the complexity and order found in nature. Another application might be mystery. So varying the transparencies of these assemblies to evoke mystery within the space. In the knee wall field, this is a good space if you're looking to do living walls, to do nature in the space, like literally nature in the space. Natural analogs could be, again, biomorphic forms and patterns, but it could also be a material connection with nature, using a natural material with minimal processing. If we look at the spandrel balcony field, one of the best ways that this can be utilized is in this nature of the space. You're having a prospect with expansive views, and maybe you have that peril. So you're seeing peril paired with a reliable safeguard. Some other opportunities here, occupiable space. So you're actually connecting to nature in the outdoors and seeing the landscape beyond, rather than going through the media of glass. So we're going to pause there for questions. Any questions on kind of biophilic design principles, how they may be applied to a facade?
If you've got any questions, feel free to go ahead and drop them in the Q&A. You can also raise your hand and we'll unmute you, and you don't have to turn your video on, but it's an option if you want to quickly ask your question out loud. So we'll give everyone a few moments, see if any questions come through.
And we'll have time at the end for questions too. If you're not quick enough on the chat, please ask away. All right, let's dive into the next part.
Cool.
So the next aspect of promoting health through a facade is increasing the indoor environmental quality. And finding ways that we can do this through the facade will help to alleviate a lot of health effects that people are experiencing right now. Let's look at some health data here. Maybe the first one to start with is that fatigue symptoms are the main cause, are the leading cause of doctor visits among the US doctor visits. So 10 to 30% of all doctor visits are spawned by patients feeling fatigue and trying to understand where it's coming from. Another one is higher math scores among students who experience higher indoor temperatures. So a 4% increase in that math score, that goes from a B+ to an A-, right? Or something like that. So temperature really does matter inside a learning environment. Another one here that I think is an interesting study, 26% higher cognitive function scores in certified green buildings. And I actually got to be part of this study. It was an interesting connection with the Harvard School of Public Health, along with a number of US-based corporate offices. And they sent sensors, air quality sensors, acoustic sensors, lighting sensors into these office spaces, and then also sent Fitbits, the fitness watch, to participants in the study who worked in these spaces. And then they would, throughout the day, maybe once or twice a day, they would send those participants a little brain game on their phone. So you would open up the brain game and do this cognitive test, and then that was it. But then the Fitbit was tracking things like your sleep patterns, your heart rate, the ways that your body was regulating itself. And they were able to control all of these different variables and find that, yeah, it's true that higher cognitive function occurs when there's higher indoor environmental quality. So let's dive into that a little bit deeper. So again, we've seen this impact of indoor environmental quality on cognitive function. We also see this through a lot of different benefits to human health and wellness through high quality indoor environments. So we're going to look at these 4 categories here: air quality and natural ventilation, daylighting, thermal comfort, and acoustic comfort, and some design principles and strategies that go along with each one of these. Recent research has shown that studies of air quality can impact academic performance, the speeds of task completion, and the accuracy of task completion. So how can we, design well using our facade for air quality and achieving higher levels of air quality? The first kind of the main aspect of this is to exhaust CO2. And we can do this either through mechanical or natural ventilation. And natural ventilation, particularly when the outdoor air quality is acceptable. So in that sense, you're looking for the outdoor air quality to have low levels of ozone, probably about 51 parts per billion or less. Temperatures not any more or less than 15 degrees from the interior room temperature. And then having an outdoor relative humidity somewhere around 60%. We'd also see reducing VOCs as an important aspect of achieving air quality. So paints, finishes, coatings, leading to irritation and respiratory disorders, trying to eliminate those volatile organic compounds. And then preventing mold. Mold growth can occur in wall assemblies if they're not properly detailed to prevent moisture and not properly sealed. So using best practices for flashing exterior materials and paying close attention to the dew point location within a wall assembly to prevent condensation from forming. The next category here is daylighting. Recent research has also shown that daylighting can lead to faster hospital recoveries as well as better sleep quality, which is a key determinant of cognitive function and productivity. So what are some strategies with daylighting? One aspect here is called right to light. So spaces that are designed for daylighting are going to have close proximity to daylighting and views. And a couple different kind of rules of thumb on that is ensuring 75% of all regularly occupied space is within 25 feet of a view window. Or 75% of all workstations are within 25 feet of view window. And then extending that, 95% within 41 feet of view window. So, and that one, you'll hear me refer to it as the 75-25 rule. So 75% of the space is within 25 feet of a window. The next one is task lighting, ensuring proper lighting levels can maintain your circadian rhythms. Ambient light levels should be around 215 lux or 300 lux for most task lighting. Glare control is trying to minimize the visual discomfort that occurs when there's high contrast between two surfaces. So in that sense, you're wanting to avoid having more than 10 times greater or lesser illuminance among surfaces. You can do that by providing interior or exterior shading devices for glazing below 7 feet, so blinds, roller shades, drapes. Similar at the transom level if you're having glazing at the transom. So you're providing interior or exterior shading devices or light shelves. The image there is showing an interior light shelf that helps redirect light within a space. The next principle here is thermal comfort. When occupants are comfortable, they're going to achieve more. Employees are going to have higher levels of satisfaction. It really does matter how your thermal comfort is impacting your day-to-day functionality. So how do we do that through our envelope? Well, one way is through minimizing solar heat gain and loss. So using your building massing and orientation to influence that thermal performance. Balancing your window to wall ratios with daylighting and natural ventilation and views and passive solar heating, all these things coming into a balance so that you're minimizing that heat gain or loss. And then selecting appropriate solar heat gain coefficients or SHGCs on your glass based on the surface's orientation, the climate, the occupancy. SHGC is just a measure of how much heat is coming in through your glazing assembly. Mixed mode conditioning. This may be a driver on your design as well. Combining mechanical and natural ventilation gives your operations some flexibility and allows for that thermal gradient that we talked about in the biophilia chapter. So utilizing effective cross and stack ventilation or following ASHRAE standard 55 for thermal conditions for human occupancy. These are good ways to measure what your building will accomplish on a thermal comfort standpoint. And then the last one in this section here is controlling thermal radiation. In cold temperatures, like I'm sitting right now in Ashland, Wisconsin, next to Lake Superior in December, and it's really cold outside. So trying to stay away from windows that have poor insulative properties because my body temperature is going to radiate outside of me and into that assembly. So looking at higher insulative properties in wall assemblies, reducing that cold feeling when you're standing next to them on the cold bay, or in cold climate areas, selecting glazing assemblies with low U factors. The next section here is acoustic comfort. Research has shown that exposure to noise can negatively affect blood pressure and reaction times. So limiting noise infiltration improves occupant comfort and reduces distractions. We can do this through a couple ways. Number one is to mitigate that outdoor sound transfer. Loud and repetitive noises are harmful. In urban areas or areas in close proximity to harmful noises, you're going to want to select glazing assemblies and wall assemblies with sound transmission class of 39 or higher, or OITC, also known as outdoor indoor transmission class, above 25 when it's near highways. And OITC and STC are sometimes they're used interchangeably, but kind of tell you a little bit more about it. STC, or sound transmission class, is more appropriate to measuring sound between spaces within a building. the OITC is better at measuring outside noises coming into the building. And the reason they're different is because the OITC tests for a broader range of acoustic spectrum. So, you know, the low rumble of an airplane flying overhead is going to appear in that OITC test where it may not appear in the STC test. You know, green roofs, again, we're looking at the envelope more holistically, not just through glazing assemblies, but green roofs can also reduce air traffic noise pollution. And then another aspect of acoustic comfort is interior noise. And one important category of that is to reduce reverb. Noise reverberation reduces speech intelligibility. So by using sound absorbing materials on interior surfaces of the facade, you're able to increase that speech intelligibility. And why, you know, why this might be important for a facade, you know, this could be something that occurs up at the transom level. You know, for acoustically treating a space, the highest bang for your buck is to treat the ceiling rather than the walls. So by placing sound absorbing materials up towards that ceiling, it's going to have a greater effect. So kind of already let the cat out of the bag with the 4 fields a little bit on this aspect, but how we can use apply these indoor environmental quality principles to a facade. So again, from the transom field, looking for better acoustic comfort, thermal comfort, minimizing that solar heat gain and loss, daylighting, you know, again, that glazing above that 7-foot floor level should have ways to control glare. Indoor air quality, you know, if you're having an operable transom, that might help with cross ventilation through the space. Let's look at the viewing field. Again, you know, operable windows, if natural ventilation is part of your design criteria, having that right to light. So 75% of your usable space, so from a workstation or classroom space, is within 25 feet of a window. Again, wanting to do some things to control glare as the sun shifts position throughout the day. Selecting high STC, OITC assemblies for acoustic comfort, especially in urban areas or areas next to noise sources. Detailing, preventing mold growth. So again, looking at your assembly and trying to determine where condensation may occur and trying to design to eliminate that potential of condensation. Knee wall. Again, we can apply a lot of these same concepts to different aspects of the facade, but one aspect here is to use low VOC indoor materials, especially if you have opaque assemblies, how you're coating that assembly, or those materials in your window construction that are low VOC. And then the spandrel balcony field. You know, again, this is an area where overhangs can act as a solar shading device to help with thermal comfort, especially in hotter areas. Or yeah, selecting higher insulative properties in cold climates. So there's a lot of different ways, and these are just some suggestions of how indoor environmental quality design principles could be applied to a facade. So we'll take a minute here to pause again for questions on anything related to indoor environmental quality.
All right, looks like we do have a question from Ennis. Do you focus on IIC impact insulation class as well?
I have not come across that,
Okay,
but
great.
it's something that we could look into. Yeah.
All right, that looks like it might be it for now. Can get back on
All right, we'll keep going here.
Yeah, go ahead. Awesome.
All right, so we've talked about 2 different aspects of designing for health, designing for well-being. Through biophilia, through indoor environmental quality, a lot of what this is pointing to is maybe more glass to help with circadian rhythms or to help with connections to nature. But as a designer, you're like, what's that going to do to us from a thermal standpoint? How is our energy use going to change because of this? So there's always a balance, right? So balancing this, you know, you're designing for these health aspects. You're pretty confident that through these designs, your occupants are going to be way healthier than you are. They're going to be smarter than you are. So you're a little bit jealous, but you need to think about the thermal aspects too, the thermal performance of your envelope. And it's important to balance that with the health aspects. So how can we do that? We'll show you a few different aspects of ways that we can reduce energy, and a couple tidbits along the way. The building envelope holds the most potential for reducing total energy consumption in the built environment. If we look at some statistics, this one is from the US Environment or Energy Information Administration, and it's showing a chart of what are all the things that use power within a building. So from commercial buildings, looking at from office equipment, cooking, cooling, space heating, of that entire pie of energy use within a building, what percentage of that can be influenced by the facade? And it looks here that 62% of the use of energy within a building is influenced by a facade, by the way it's designed, by the way it's performing thermally. So facade performance is vital to conserve energy consumed in buildings. So we've got some principles on ways that we can reduce energy. One of the earliest decisions affecting sustainability is the overall massing and orientation of your major facade and roof surfaces. So we'll look at building geometry and orientation. We'll look at window to wall ratios, and we'll also look at material performance as a way to reduce the energy using your facade. So starting with building geometry and orientation. If you're looking at using natural and passive aspects of design in order to reduce your energy loads, we're likely going to have a lot skinnier buildings. If we look at that 75-25 rule, we're looking at depths of floor plates beyond 75 feet being less effective, especially as we're trying to get natural ventilation and natural lighting into those spaces. Beyond that, you can use atria and courtyards to accommodate that daylight access and natural ventilation. Building height, as wind speed and pressurization stack effect need to be carefully considered in taller buildings. You also need to look at occupant comfort, knowing it may diminish above the 8th floor. Some ways to design for this is through a double envelope design, which can help mediate wind pressure, especially at higher elevations. And building orientation, positioning your building to take advantage of local climate phenomena. That can really reduce your energy significantly. Avoiding locating cooling equipment on rooftops and west-facing facades where they're going to be, inundated by solar energy, or orienting to take advantage of prevailing winds. Ideally, those winds are passing through a landscape, so some of that air quality is being improved as it's passing through that landscape, but just some design principles surrounding building geometry and orientation. Another category here, window to wall ratios. It's strongly advised you just use a ton of windows, just more the merrier. This is something that we have found to be true. I'm completely joking here. We're a window company, so we just want you to use a lot of windows. But in reality, window to wall ratio is something that needs to be considered. So what's the prescriptive path and what's an energy model, and how do we design window to wall ratios? The prescriptive path is a conservative approach based on generic project data. So using jurisdictions and certifying bodies, code compliance requires certain window to wall ratios, and that's energy code compliance, right? In most places, based on your location, based on your facade orientation, your window to wall ratio using this prescriptive path is probably between 18 and 60%. Another approach is using an energy model. So this allows you to model all of the variables parametrically based on your project design goals. So all the energy use in the building, and then be able to do some trade-offs. So there's various software packages approved for these certified energy models. One clear thing is to work with manufacturers to provide accurate modeling components and testing reports to make sure that your energy model is accurate and it can actually do the work that you're expecting it to do. So I do want to talk a little bit more deeply about window to wall ratios and just show you that how you fill those holes in your building has a really large impact on overall thermal performance. I want to show you a resource that is actually here on Acelab, and I'll just open up my browser here. So Bo was showing you the Acelab platform. If you go up here to resources, you click on building science courses. This is a whole bunch of wonderful tutorials from Christine Williamson. And if you click on Windows, there's one here that's, I think, is really excellent. And it's this one here, Why Glazing Matters So Much More Than Insulation. It's a 9-minute video full of really great information, looking at how an assembly, a wall assembly and a window assembly are calculated, their thermal efficiency or their R value is calculated. And what you'll see in this presentation is why window performance is so critical to overall envelope performance. So I commend that to you. Go and watch it. But in the meantime, we'll go back to our presentation and point out one aspect of this window to wall ratio. You'll see a lot more about the math behind this in that presentation on Acelab, but what I want to show you is looking at different window to wall ratios. So these different color lines on the bar graph are different window to wall ratios. And you're looking at thermal efficiency of those, of a wall assembly, where you have, on the left-hand side of the chart, a window with a U factor of 0.36, and on the right-hand side, a window with a U factor of 0.16. And even looking at like a window to wall ratio of 70%, which is a pretty generous amount of windows, improving the U factor of those windows from 0.36 to 0.26 improves that overall average R value by 36%. And then going from a 0.36 to a 0.18 will improve that R value, the average R value, by 92%. So what does it take to go from a 0.36 window to a 0.18 window? Well, it's usually jumping from a double pane IGU, insulated glass unit, to a 0.18, which could be a triple pane glass unit. Usually going from a 0.36 to a 0.18, there might be some sort of frame improvement as well, where you're going from maybe a frame that's not thermally broken to one that is. But what you're seeing here is the minimal cost going from kind of a non-thermally broken double pane window to a thermally broken triple pane window. The cost is way outperformed by the energy savings. So for a company like us, going from a double pane window to a triple pane window represents somewhere around a 10% price increase to the cost of the window. So looking at price increase resulting in 92% better performance, it's something to consider, right? There's an impact there. All right, enough about window to wall ratios. Go watch that video right after this. You'll love it, I promise. All right, the last principle here on reducing energy through the facade is about material performance. We'll look at this kind of in two sections here: air infiltration and thermal bridging. So air infiltration is reducing the amount of air that's coming through your assembly. That air is, it's got maybe some condensation in it, it's got air vapor in it that can turn into condensation. It's also likely cooler, so you're having to condition that air once again. So trying to reduce air infiltration is really important in facade performance. So you're looking at glazing assemblies with air infiltration rates probably less than 0.3 cubic feet per foot square when 6.2 pounds of pressure is applied to that. And then paying close attention to the detailing of it, making sure that you're installing in a way that is preventing, nail holes from being sources of air infiltration. You can do some testing on it as well, performing pressurization tests. So ASTM E783 for air infiltration, ASTM E1105 for water penetration. I do have a story on this. There was a school that we were working on in northern Minnesota, and they had they're looking at oftentimes building performance using high performance buildings, creating them is about a 10% cost increase than a conventional building. And this school in northern Minnesota, design team we worked with, were hyper focused on air infiltration. And what they found is that they could significantly reduce the cost or the loading, the HVAC loading, by really keeping a tight envelope. So having really close scrutiny on air infiltration. And they found that by focusing on air infiltration, they could actually reduce the size of their mechanical system, and that reduction in the mechanical system offset the cost of the higher performance facade. And it was a passive approach, meaning they're experiencing that thermal savings every single day from the beginning of the project. So one kind of just tidbit of the importance of air infiltration. Thermal bridging is another issue that is really important. Heat loss due to thermal bridging accounts for between 11 and 29% of all building energy consumption. That's a significant amount of energy. So to combat this thermal bridging, you're going to want to select elements that, minimizing the structural elements that connect conditioned interior space with unconditioned exterior space, and utilizing materials with low conductivity for thermal breaks within the facade. One example of this is a timber curtain wall. So this is an isothermal diagram based on finite element analysis showing reduced thermal bridging of the timber curtain wall compared to a traditional aluminum curtain wall. What you're seeing here is when it's 2 degrees outside and 69 degrees inside, that aluminum mullion, the surface temperature, that is about 9 degrees colder than room temperature. And meanwhile, the timber mullion is at equilibrium with the indoor temperature. So if you're standing next to that aluminum mullion on a cold day, you'll feel that cold radiating out from your body, or you'll see energy leaving your building through that mullion condition. So again, 11 to 29% of all building energy consumption occurs through this heat loss, thermal bridging. So let's apply this to the 4 fields, and then we'll take some questions. But looking at transom field first, building orientation and geometry, utilizing narrow massing to maximize daylight, window to wall ratios, again, positioning glazing where deep light penetration is most likely to occur, and reducing that glare by being able to use light shelves or something like that to bounce that light deeper into the space. Material performance, utilizing materials with low conductivity, and detailing for reduced air infiltration. Some similar concepts here on the viewing field, but positioning glazing where natural ventilation and daylight and views are most important. One other tidbit on this is understanding that an operable window was going to perform is going to have lower performance, thermal performance, than a fixed window or a direct set window. So if you don't need that many operable windows, reduce them, because your envelope performance overall will increase. But balance that with your natural ventilation aspects. Looking at knee wall conditions, again, avoiding locating those facade integrated mechanical units on Western facades, thinking about in-wall units that you'll see in hospitality projects. Oftentimes those, you can't avoid them, but in some places, you might be able to relocate those mechanical units so they're not being inundated by the sun. And then on the last kind of aspect here is the spandrel balcony. So again, detailing for reduced air infiltration. Utilizing a double skin facade or positioning these spandrels to prevent light where you don't need it, to shade certain aspects of the facade. So reducing energy through facade performance is really critical, and also allows you to do those other aspects of the project that you're trying to achieve. Better health for your occupants, better performance for the that are occurring inside the building. So with that, we'll open it up questions just generally too. So.
Right, awesome. Thank you so much, Bryce. Looks like we do have a question from Vincent. Great presentation. Can you go over how the best practices presented may differ for a cooling only environment in ASHRAE Zone 1 or Zone 0?
Yeah, I think one of the main aspects in that is certainly working at your SHGC. So you're not having so much solar load come into your building, doing things with light shelves, doing things with overhangs to prevent sunlight from entering the building. I'm not as familiar with warm weather climates. I live in the Twin Cities, Minneapolis, and so most of my work in the past has been in cooler climates, but there are a lot of different opportunities through natural ventilation, through positioning, even if you're looking at cross ventilation, how you're positioning windows, low on one side, high on another side, to use natural drafts that happen as temperature gradients occur through the height of a space, to help lead to some of that natural ventilation pulling the cool air in. So.
Awesome. And it looks like I do see someone with their hand raised. So Kevin, I'm going to go ahead and unmute you, and we'll see if you have a question to ask out loud. All right, let's see. Hey, Kevin, did you have a question, or are you just raising your hand on accident? Looks like it might have been an accident. All right, I'm going to disable your talking, but if you do have a question, feel free to raise your hand again or throw it into the Q&A. All right, let's see. We've got another one that came in here. Oh, no, that was the same one that we answered. All right, cool. So while we give everyone another moment or so to see if there are any other questions that come up, I just want to send a reminder that we've got quite a few links in the chat that you might want to grab before you head out for the day. There's a link to the H-window profile on Acelab, a link to sign up for a demo of Acelab. There's also a link to that course that Bryce was talking about. So definitely go check that out. If you haven't taken any of Christine Williamson's courses in the past, she's a really great educator. And we've got a ton of those nano learning courses on the platform. They're all like 10, 15 minutes, so it doesn't require a lot of time, but they are super great and helpful. And I believe actually they might be, I think, reinstating the AIA approval over the course of this week. So if you want to hold off for another day or so, we will be letting you know once we've got that AIA approval back, and you'll be able to take a short quiz and you get like a quarter of a credit. So stay tuned for an email about that. We're going to be letting folks know, but that'll be another great way you can potentially earn some credits before the end of the year. All right, and while we hang out for another moment or so, give you some time to grab those links and see if there are any other questions. I'll just share my screen quickly and recap some stuff that we covered at the beginning in case anyone joined a bit later. One moment here. All right, so here's that course page that Bryce was talking about. We've got a link for that in the chat. A few things to bring up. So this resources tab is a really great place to come for building science courses. We also have a construction detail finder, which is super helpful, a bunch of great articles, and we also have recordings of all of our past webinars. So if you're looking to, learn some more, you can check those out as well. What I want to show you here is if you know exactly who you're looking for, you can always use the search bar at the top to type in the name of any brand, any product. It'll cross search between product categories, brands, and resources. So sometimes you just have to toggle to see if it comes up in the right place. And then you can jump over to their page on Acelab. From here, you can get in touch with Bryce directly. So this is a great place to come if you want to discuss a project or get some more information. And then scrolling down here, you can view their products. You can save these to your firm library or to your projects. And you can also open up any of these product pages. That'll give you some more information, as well as that button to get in touch. You can view, more product information. Scrolling down here, you can view finish options, different customization options, as well as performance data, glazing options, certifications, and downloads. So this is a really great place to come if you're looking for some more product information, you want to get some product literature, construction details. You can explore all of that on this platform. All right. Last thing I'll mention actually is that if you do get in touch with Bryce through this or through the poll that we've got launched right now, you're going to get a conversation created for you on your Acelab account. You will receive emails about those. You can reply directly to your emails, so you don't have to open Acelab's platform, but it can be helpful if you want to just get an overview of all the communication that you've got going on. So if you want to go to your conversations on Acelab, you just click this icon in the top right. That'll bring you over to a page where you can view all of your open conversations on the platform. Then through here, you can, collaborate back and forth. You can upload your project files, update project details. It's a really great way to kind of keep your conversations all organized with your project research. So if you have any questions about that, again, there should be a meeting link to sign up for a quick demo in the chat. Last thing I'll show you while I have you here is something that you can also ask our team to help you out with setting up. So this is our schedules feature. We're releasing this to beta users, so if you want to get some early access to this firm library schedule feature, you can just let us know. Basically, it's a really great way to store all of your product information that allows you to pull in data from Acelab's platform, as well as all of your own custom data. So you can really make it work for you and your firm. It also saves you a bunch of setup time because we've got a bunch of data already uploaded, so you don't have to kind of, plug it all in manually. And then you can bring in any data that you need in terms of, different statuses, different client names. It'll also automatically load any reps that we have on the platform. So that's a super great way to keep all of your contact information organized. And it's very collaborative. You can comment back and forth. You can share different views with different collaborators and team members. So if this is something you're interested in helping, getting some help set up, we are happy to help, take your project files, take your spreadsheets, and really work through them to make sure we get your digital firm library all organized and uploaded. And from there, we can also help you out. Oop, looks like I froze a bit. But from there, we can also help you out with any recommendations. So if you go through this process and you're like, oh, I've been using the same window for the past, 3 projects. I really want to try something new. You can reach out to our team about that, and we'll help you to, evaluate different benefits of different window options and, why you might want to switch to a different standard. So tons of different ways to use the platform, whether you're just looking for, educational resources or looking to kind of get your digital library all set up. And we're happy to help you out with any of those services. All right, let's see. No more open questions. Wow. So you must have done a really great job presenting, Bryce. Seems like nobody had anything else that they needed to clarify. If folks do have questions that are coming up as you're leaving today's webinar, there's going to be a quick post-event survey. Feel free to leave any feedback or any questions there as well. And we can follow up with you after today's event. You can also head over to Acelab's platform, get in touch with Bryce directly there. That works as a great way to, ask any follow-up questions or connect about a project. All right, awesome. Well, I guess then we'll just give one more reminder, grab those links from the chat. Looks like we've got some thank yous popping up in the Q&A. So thank you so much, everyone who joined us today. We appreciate you coming out and attending. And I hope you have a great rest of your Thursday. Thank you so much, Bryce, for an excellent presentation.
Oh, thanks, everybody.
Okay,
Happy to be here.
bye.